Hello everyone, this is the video tutorial about a Medium article, Unusual Bet, Can Machine Learning Guarantee Racecourse Gambling Returns? So let's move on. So I will introduce the topic, like using the text in the left side, and most of the time I will use the right side of the screen to show practical examples with the code base. So let's start. Horse racing has traditionally been seen as a gamble, where chance and the random performance of horses decided the day's winners and losers. I think this is pretty straightforward. Yet the rise of machine learning and sophisticated data analysis is shifting the field, revealing how betting can evolve beyond pure chance to become a matter of planned strategy. Given the complex nature of creating a machine learning model that can reliably predict outcomes where a task is incredibly challenging, this post aims to tackle the subject of risk management head on. It shows what one can realistically expect from applying machine learning as a tipster to the unpredictable world of horse race betting. So, let me explain you a bit in an informal way. When I was visiting the York Racecourse, I started to think, all right, how how can I basically create some kind of betting strategy to make some money on the racecourse gambling? And I immediately went home and I started to check what's going on Kaggle with data sets. And what I found basically that almostly everyone suggests to create like a machine learning model which predicts the outcome. Hence, like I decided, okay, let's do this. Let's do machine learning plus some kind of quantitative finance stuff like arbitrage. I'm not going to introduce the concept of arbitrage in this video just to save some time, but uh, let me explain you. Imagine if you have a bet where you have just 8 horses and with like some distinct probability of winning, you know that just 3 out of 8 horses will definitely win, but you don't know each one of them. So your task is just to basically bet on all of these horses, all of these 3 horses. And since you know that just like one of these 3 horses definitely wins, you will obtain the profit from this. So but you have to know which 3 horses, of course. That's where the actually machine learning come in this example. Let's move on a little bit further. Yeah, that's what I just said. And this is where machine learning enters the fray. By harnessing the power of predictive analytics, a machine learning model or a horse tipster can sift throughout vast arrays of data to identify the most probable winners in a race. Imagine a scenario where n horses, each with a distinct probability of winning based on factors analyzed by the model. The key lies in selecting the right combination of these n horses to create a scenario where the total probability of winning is less than 1, yet the collective odds offer a guaranteed return, the essence of an arbitrage opportunity. So basically, this arbitrage opportunity is the last layer of this strategy, and all kind of machine learning is above this arbitrage opportunity. So, and yeah, obviously this is super complicated task to create like this ML horse tipster, and I decided firstly to basically check, all right, what I can get from this just by simulating some stochastic processes using some kind of probability and simulations to understand whether should I do some machine learning on this or not. So, and this is just why I wrote this article basically. All right, let's move on to the code. Like I'm using here just some few external libraries like NumPy, Pandas, Matplotlib, Seaborn, .env, but this .env is not used in the examples. Okay, let me show you how the data looks like. Let me say a few words about dataset. So in this case study, I got dataset from Kaggle, horse racing tipster bets. and this is not realistic races. I made like pseudo-realistic races. This data set was basically about how to create ML for tipster, but there was nice form of this data set, and they provided an odds to each of the horse. So I decided, all right, let's create like a real pseudo race on this. And right now I'm going to introduce and show how basically I form a whole data set for this problem in Python. So, okay, let's go. Let me show you firstly how the data look like, initial one. Yeah, so just the simple basic IDs, the name of the tipster, who suggest the uh, like to bet or not to bet, the date, the track, the horse, the bet type, odds basically, and result. And here I created two more columns. I will explain you why. So first of all, to create the data set of each races, we have to follow some rule, and this rule is basically the date and the track. So I decided to create a key, which consists of date and track, and after I'm going to group this data set by this key. Also, I have to mention that I consider just bet type, which is win. In this data set, there is like each way. I'm not going to do this. I'm just doing with bet type win. All right, let's move on to this grouped data set. Let me show you this as well. Yeah. So I grouped this data by the key, and I obtained this result. Also, I calculated the len of how many horses in each race. I checked is there is just one winner in this race, and I also calculated how many winners in this race as well, because it's not like it's pseudo real race. So in some cases there was like, oh yeah, you see 6 winners in one race where there's like 23 horses. So, okay, after I started to filter this data, this is simply the filter. I'm just considering just one winner in the race, more than 6, less than 25. And yeah, I obtained with 555 races. Uh, when I firstly did simulation, I thought, all right, it will be enough. But after some few simulations, I decided to expand more data and look at the races where I have more than just one winner. So this is pretty straightforward. If I have more than one winner, I will just use numpy.random.choice to decide which winner to get from this list. And when I concatenate both filtered data and additional data, I obtained with 900 races. So, all right, let's move on. Yeah, to more precisely to more precisely show our simulation and believe in our simulation, we also have to filter our data set from margin. We can't consider margin which is below 100 because it's immediately will be arbitrage opportunity, and we also can't consider margin which is above like 250 in my opinion, because like in real life no bettors won't bet on the race where it's just like 400% margin, right? This is like too much, and better won't obtain anything from this. So I decided to drop this as well, and we just considering this area, and also I'm considering from 10 horses to 25. Yeah. So this is the filtration, and yeah, we can see there is like log normal distribution. Here is like more uniformal distribution, I would say. Yeah, and bets from 100, margin from 120 to 250. Okay, now we're moving further and I got my target races. This is just an example and provided here. And we're moving to more complicated code. Yes, let me start from here. So basically when we obtained with our data set with all our races, we have to build some kind of distribution of arbitrage opportunities. So we have to understand what is the expectation of arbitrage opportunities through each race. So how I'm going to do this? I just decided to do some kind of Monte Carlo combinatorial algorithm where I have m iterations. On each iteration, I select how many odds I will consider in one race randomly, and after I randomly select these odds, like this, for example, this variable gives 5 and puts here, and I get like a random list of 5 odds. And after I'm checking the simple condition, if the sum of these inverted odds less than 1 minus inverted winning odd, I'm appending this combination to my list of valid combinations. So this is just basically super straightforward algorithm of creating the distribution of arbitrage opportunities through each race. So, and that's how it looks like. And also, yeah, also I have to mention, but probably it will be later. Yeah. No, it should be right now, I think. Okay. Yes, let's suppose that we have this example, and in this example we have 11 horses, uh, like 10 here where we can find an arbitrage with them. So here we honestly can't consider like 2, 3, 4, 5 because this is not really true. Like our machine learning model like can't be super much precise even in real world to select just 2 horses which can give 1000% of return through each race. This is like pretty impossible, I think, and I decided to take the 50% floor of the horses. Like we have 11 horses, we multiply by 50% and taking the floor of this number and filtering and getting basically what is above this number. So yeah, the green area is what we consider in each race, and where we're taking the expectation of an arbitrage opportunities through each races. Yeah, and this is basically this code, pseudo expectation, possible ML classifier, horses in race, greater or equal than floor, and we consider this one, and we getting the expectation from this. All right. All right. Yeah, and also this code related to the arbitrage. Here, how I said, in the text you can see that about algorithm that in this case, the first step in Monte Carlo combinatorial algorithm is to identify the winning odd. So basically the function experiment starts from identifying the winning odd and just do some processing and after put to the arbitrage function, which I earlier explained what does it mean. Okay, let's move to the simulation. So yeah, we run all of these pseudo expectations through each of the races which we got. We got 209 valid races. Remember considering this area. And we obtain with this result. So basically This is like for 200 races, we can get like 3,500%. Like if our machine learning model will be 100% corrected all the time. But yeah. All right, let's move on to how I'm going to model machine learning accuracy. I decided to use like F1 score to consider F1 score as a metric of our machine learning algorithm. So like this is precisely explains the precision and the recall of the machine learning algorithm. So F1 is considered. And we're considering accuracies from 0.97, 0.95, 0.9, 0.87, 0.85, and 0.8. And what we are doing, we are basically generating through each Monte Carlo simulation stochastic binomial process where the success rate of the binomial variable uh, equal to the accuracy, to the considered accuracy. And if our binomial random variable gives 0, we change the payoff instead of some profitable number, we change it to minus 100%. And yeah, these values are also in percent. And these values are also in percentages. All right, and here is basically the result. The black line represents like F1 score equals to 1. And also I'm considering the value at risk 10% significance, means that with 10% chance to be there. And here we can see like nice picture, not really nice picture, but like a real life picture that to basically earn some money from this kind of strategy, we have to have our F1 score bigger or equal than 0.95, which I think with like we have to be well organized and well resourced to do kind of machine learning to obtain this accuracy, honestly, for finding the best sequences of arbitrage. So yeah, like considering 0.8 F1 score, like your expectation of this distribution is basically less than 0. So you will lose the beginning of few races and you're done with this accuracy. And also if we're going to consider even the drawdown processes of, for example, the second simulation, we can also like exclude this accuracy from our research because the drop down here is also insane, and probably for somebody this drop down would be too much. All right, and let's go to the conclusion. So in conclusion, the exploration into the application of machine learning in horse race betting reveals a landscape where strategic planning can significantly influence outcomes. The rigorous analysis from evaluating arbitrage in simulating races to modeling the accuracy of machine learning tipster underscores the necessity of precision in predictions. The findings from various accuracy levels indicate that a highly precise model achieving an F1 score between 0.97 to 0.95 is essential for a successful arbitrage strategy. However, attaining such high accuracy consistently is an immensely challenging task, perhaps only with reach for organizations with substantial resources. Sorry, only within reach for organizations with substantial resources. Yes, unfortunately, it is the truth. To not to mislead ourselves, I think we have to do some kind of risk management to all our decision making and to all our strategies research, even in trading as well. So, okay, thank you very much for watching and good luck.